Hello everybody. Well, hope everybody had a good Christmas and a good New Year's. Hope Santa brought you everything you wanted. I'm going to talk today, this is the piece of test equipment that maybe will come in handy before we start building the shortwave receiver. The tube I'm dealing with here today is a 12BE6. There's several versions, has to do with the filament voltages. There's a 6BE6, a 3BE6, a 4BE6, and then of course the 12BE6. Each one of those is just, the first number has to do with the filament voltage. They're all the same tube. And they're a very unique tube, and as opposed to all the rest of the tubes that you could use for receiving, this one has a special purpose and design, and it's called a pentagrid converter. It is designed for mixing, and it can oscillate on its own with a circuit hooked to its cathode, and it can mix another incoming signal, and it's used as the mixer or converter stage ahead of your IF system. Normally some receivers, like the little table radios, just used either a loop stick antenna, or if some remember back far enough, the whole back of the radio had like wire wound and glued in on a flat surface at the back of the radio, and that was the antenna, and those were just the AM table radios. Those radios didn't usually have an RF amp. They just fed that antenna through the tuner that you'd tune the stations with, and they'd feed that into the signal input grid, while the rest of that BE6 was used as the oscillator that would tune the stations. And this little project, we're going to use two signals to input and come up with a different signal on the output and use that for tuning our receive coils. These little devices are called TCXOs. Stands for temperature compensated crystal oscillator. And here's what they look like in the raw. There's the full-size can, and they have one they call the half-size can. And they have pins that you connect to. Very simple to hook up. And just like I've got it on the drawing here, it says bottom view, sharp corner. They have rounded corners on three corners, and just one of the corners is a sharp edge. And that's your key to how the pins are hooked up. In other words, this would be the ground, just like I've got it shown here. This circuit is, the schematic is drawn as if you're looking just like this at this part. The 5-volt input is on this pin, and directly opposite is the ground, and opposite the ground on that same side is the signal or the RF output. The little half-size can is exactly the same wiring. It's just a smaller footprint, depending on how much room you have and that you want to use. Now, how I hook them up is, because I want them to swap them out for different uses, I hook them on a little piece of copper-clad board. These two TCOs here will combined will output the 15-meter band a signal, so that I can tune an antenna coil to 21.0688, and that brings it in close enough to where you can get at the rest of your 15-meter signals. I start with a ground wire, solder it to the board. Maybe you can see it here on this one. Maybe in the, I don't know how that cameras will pick it up. Anyhow, I start with a ground wire, I solder it to the board, leave it hang free Then I move the little oscillator case up to it, put a little bit of a curl around the end, make sure it's not touching anything, and then solder it. That holds the oscillator can in place. Then I can place the Zener diode, which gives us our 5-volt source. I solder the negative end of it to the board, then lean it over and do the same thing. A little bit of a curl around the leg, and then solder it in place. And then I feed that with a 470 ohm, or in this particular instance I use a 1.5K 1 watt resistor. That's the Zener diode. They're a 5.2 volt 1 watt Zener. That way you don't have to worry about coming up with a separate 5 volt supply. You can just use 12 volts. You feed it through a resistor, the diode takes care of everything but the 5 volts. And you get a 5 volt voltage to the little can to make it oscillate. Okay. And like I say, I made these with a hole on them to where I can just bolt them down. And this is how I've got it mounted in this little chassis. You can see that in there. You got 2 TCXOs, and then a screw just grounds it and mounts it to the case. The tube socket, I connect to it with the ends of the little disc capacitors. They're 22 picofarad apiece. And instead of putting any resistors on the tube to ground, I do that right on, you can see them in there. I use a 1 meg resistor and just use that as a tie point, as a place to hook my 22 picofarad cap from the output over. And that isolates the output of this to the grids of the tubes. And on this particular one, it'd be grid 1, the signal, the oscillator, the input grid, the mixing grid, and then the signal grid gets the other one. Doesn't matter which one, by the way. You don't have to, like the lowest frequency doesn't have to go in one while the other frequency goes in the other. It doesn't matter. You could swap them around. It's just how I had them set up. So the combination of these 2 TCXOs, one of them is 22.1184 megahertz, and the other TCXO is 14.9105 megahertz. And the difference between those two is our 7.2079 megahertz. And that's what we're using for our 40 meter. It's kind of centering up in the 40 meter band, so we can tune our antenna coil. Now the reason for this is there was a viewer overseas that got me thinking about the availability of these slug tuned forms. He used a 1/4 inch wood dowel, and I thought, you know, that's right. They may not be able to find these kind of coil forms. So I thought, well, I'll come up with an easy way for them to tune the coil, tune it in first, to find out how much capacitance you have to put across that coil to make it resonate. So what I've done here, this tuner is 250 picofarad. Now I don't know if you can see the marks. This is just, threw it together real quick just to demonstrate. So like I say, it's not fancy. And I marked off every 50 picofarad. Like here's 50, here's 100 picofarad, 150, 200, and then 250. So when I tune the coil to resonance, and I'll show you that here in a minute, to where I get my frequency that I want, I peak it to the highest point. Then I unsolder everything, take a, probably can't, oh, here it is. Take a capacitor checker, if you have them. This would be handy. This little guy here is really slick. Found it on eBay. I think I paid $18 for it. Anyhow, you would put one to ground, one to one of the leads of the capacitor. Well, you know, you unhook the coil and everything. Then you take a reading, and that reading then can be made up with some just simple silver micas or what have you. Oops. Like that. You'd use whatever value you needed and combine, and then just simply mount it across the coil. Then that coil is ready to put into the receiver. Now this is, you would do this if you didn't have separate tuners, like the little trimmers, like you'd mount on the front panel or something. So just a simple fixed tuned will put it at the middle, basically the middle of the 40 meter band, and you won't have to repeak it. If you maybe have a 5 or a 10 picofarad, you could add to that that's below the total. Then you could either remove that or add another one to move the frequency tuning up or down a little bit. It's once you get the receiver together, you'll see how that works out. We'll show how this thing tunes up now. Put these away. Okay. Now this little guy runs, this is the fun part, runs with only 12 volts. The tube filament is 12 volt to 12 BE6. And the tube will actually operate on 12 volts plate voltage, and it'll do the mixing. It doesn't have to do any oscillating because we're supplying it with those 2 crystal oscillators. So we'll let that warm up just a little bit. Turn the voltmeter on here. Okay, we're pretty close. It's still warming up. Yeah. Now, what this is, I'll show you what this is in a minute. This is just a voltage doubler, and there's a 10 picofarad cap, a little disc capacitor that runs a sample just to from one of this side of the capacitor out and feeds a pair of diodes arranged in a voltage doubler. And I'll show you that circuit in a minute. I call it my RF probe. It just turns a little sample of RF into a DC voltage, and then that DC voltage can then be read on the meter. Here we have a little over 3 volts. About 3.1 volts is how that's setting. Now see, if I tune this tuner now, off resonance, see it drops, goes way down. So what you look for is you tune this to get the highest. Oh, there we go. We got a 30. We got 3.1 volts. So now what I would do, turn everything off. You wouldn't bother the tuner. Unsolder the pieces away from the little capacitor, and then measure that. Then you could take that number, and it should come out around 88 picofarad. And you'll see, let me unhook this, I'll show you what I'm talking about. Since I have this little capacitor already marked, not sure it shows up, but here's the 50 and here's the 100 picofarad mark. You can see where it's sitting. It's right about where it should be. That should be about 88 picofarad. And what I was getting at is you could take, if you didn't have a capacitor that's exactly 82 picofarad, you could take a 62, which is a commonly available in a silver mica, 62 picofarad, and then a 22 picofarad, and add it across that. And the two combined would be close enough to make that coil be close enough to peak that you'd have pretty good receive. Now, okay, I'll show you this. I don't know. I've got schematic. If you want them, just let me know, and I'll send you the schematics of this. Everything from right here on is that little RF probe that I was telling you about. Here's the 10 picofarad cap. There's one I use switching diodes, similar to like a 1N914. I think the one I'm using are 1N4148s or something like that. One diode going to ground, the other diode forward for positive output, and then there's just a disc capacitor, a 0.01 disc capacitor is across the diodes. That's what you're seeing right here. Yeah, you can see it. I don't know if you can see the diodes if the camera's picking them up there. There's just two little tiny glass diodes. One there, one right there. And then they're just tied to ground. And I just got them tied across the disc capacitor. It makes it easy to mount them. And then, like I said, here's a little 10 picofarad cap that samples. And that's a real simple little RF voltage probe that you can use a cheap little digital meter to read, and that will get your RF coils. The first thing we'll build when we start building the receiver is we'll have to make two of these coils, one for the grid, one for the plate of the RF amp, and by tuning them up with this method they'll be close enough that once you get some signals and send a signal through them, you'll see that they'll tune up quite nicely. Okay, thing that happened today, right? I actually discovered this new parts house called BG Micro. I had never heard of them before, but I was looking for IF cans. When we get to building the receiver, I'm going to need a source of these little 455 KC IF cans. And I pulled mine out of some old CB radios. But I wanted to find a source that I could direct people to that was cheaper than what you find on eBay. They're just absolutely crazy what they want for these things. Some people are trying to get $20-some a piece for the little bit bigger IF can. Let's see. I think I got one here I can grab. Yeah. This thing come out of a Johnson radio, a Johnson CB, but they're similar to this. Well, you need 3 of these. And they're quite expensive. I didn't really realize how high priced they had gotten. But BG Micro, I just simply did a Google search, 455 KCIF transformer, and they showed up with a full set of 3 for I forget the price now, it's $1.50, $1 something for all 3 transformers. So what I did is I ordered several sets. I will, when they get here, I will do an unboxing, and later I will hook them up, and I will then let you know if those transformers did indeed work. But BG Micro, bgmicro.com, I'm not affiliated with them. I just discovered them last night, like I said, and I placed my order as almost a $100 order today. They also have some interesting tubes, $2 a piece. They're an oddball tube as far as the filament voltage goes. They're a 3BZ6, which in common tubes I normally see the 6BE6 or 6BZ6 version of that. But looking it up in the tube chart, it's exactly the same as my 6CB6. It's the same pinout, so it's a direct plug-in. The only difference is the filament voltage. And I seen them in there, and they wanted $2 a piece. They're brand new. They're made by, well, I don't know who they're made by, but they're packaged and branded Allied Radio. So I bought 5 of them, so I'd have one spare. And it's really simple. The receiver is going to need 4 tubes, 2 in the IF, 1 for the BFO, and 1 for the RF amp. The other tube is the 12BE6. But if you tie those filaments together, all 4 of those 3-volt tubes make it to where you can hook them series string and hook one into 12 volts. So 12 volts will run that whole string of tubes. So I have those coming, and when I get them, I'll try them out and see if those tubes do indeed work the same as the 6CB6. Along with that, they had some tuners, some variable. They're not quite like this one, but they're a 200 picofarad. I think they're a 5-section cap, but they're similar in construction. This one pulled out of an old Yaesu 101. And the nice part is it's got a gear drive, and when you hook it, couple it up, you can turn this slowly. Now the little caps that they have don't have this. I just added this on here, but the caps are just basically this thing right here, and they're I think $4.95 a piece. But they have some sections are like 30 picofarad, several of those, and then a 200 picofarad section, and it will be just perfect for a shortwave receiver. So I'm going to get those and test it out, show it, see how they work, and let you know if they're a pretty good deal. Now they had some TCXOs also. Really ridiculous price. 5 of them for 20 cents. So I couldn't pass up that. They're 14 megahertz. What I have written here, I know the camera can't pick this up, but what this is a list of TCXOs with the 2 frequencies given the output, like a 22.1184 and a 5.0688 megahertz TCXO will give you a signal out on 27 megahertz. If you want one for the 21 megahertz at the 15 meter band, then a 5.0688 and a 16 megahertz TCXO will give you 21.0688. And there's one here for the 20 meter band, a 15.741 and a 1.544 megahertz will give you 14.197. And some others is a 4 megahertz if you needed reference for whatever. A 15 and 11 give you 4, a 16 and 11 gives you 5. The one I didn't write down here is the obvious. A 15 and a 16 will give you 1 megahertz if you're trying to tune something up for the middle of the broadcast band. You could use that. All with this same setup. You just use whatever TCXO you need and come up with the coil. An online coil table is really handy. This particular one I've repeated on the other schematics and stuff. It's 35 turns on a 1/4 inch form, 30 gauge wire, and the capacitance across it to bring it to resonance is about 88 picofarad. and that's for the 40 meter, middle of the 40 meter band. Okay, that'll do it for now. If you want the schematics, send me an email. Tell me what ones you want. And this one here, I have the schematic with the oscillator and this little RF probe thing. I've got to redo that a little bit, and it'll be ready to send out here in a couple days. So let me know if you want the schematics, and I'll mail them out to you or email them out to you. Let's see, the next video will be on that schematic. 2 tubes. It uses a 6BE6 and another tube, and this will also be used as a tube tester, and I'll explain all that on the next video. So come back for that one. Okay guys, thank you for watching, and see you next time.